Electron configuration tells us location of electrons in an orbital for any element you choose.
Valence electrons are on the outer shell of an atom, which can combine with other atoms to form molecules.
Now I'm going to explain the sublevels. Over here in pink is sublevel S. It's the first and second. And from 3 right here all the way over to this one is D, and it's in orange. And then when you get farther over here, from here to here, it's the P level. Then when you get down here in the very bottom, it's the F levels. And you need to remember that whenever you're writing electron configuration. The energy goes from left to right. Over here has less energy than over here. The more you fill up over here and going over here, the more energy the electron has for configuration.
Electron dot structure are valence electrons that are represented by dots placed around a chemical symbol. This would be an example.
We can write the electron configuration of an element based on its position on the periodic table. Valence electrons are the outermost electrons and are involved in chemical reactions. We can write electron dot formulas for elements which indicate the number of valence electrons. We can predict the charge of an element by the group it's in. If it's in group 1A and it's a metal, it's normally a +1 ion. If it's in group 2, it's normally a +2 charge, and group 13, which would form +3, and group 14 metals are +4. By losing their valence electrons, they achieve a noble gas configuration. Similarly, nonmetals can gain electrons to achieve a noble gas configuration. Group 15 elements form a -3 ion group, and 16 elements are -2, and group 17 is a -1 charge.
In the example presented, we are using carbon as the element, and I'm going to show you how to do it on the periodic table. So as you see, carbon is right here, and you start on this side, and this is sublevel S, so this would be 1s2, as presented right there, 1s2. Then you drop down to the next level, which would be row 2, and you go 2s2, so there's 2 right here, so 1, 2, so 2s2. Then you jump over here, and you do 1, 2, so it'd be 2p, and this is sublevel P all right in here. So it'd be 1, 2, 2p, and then 2, just like this. So 1s2, 2s2, and 2p2. Now for the condensed version. Going back to the periodic table, we are using carbon, right there. In previous, this is how we wrote it, 1s2, 2s2, and 2p2. But there is an easier way to put it. You have carbon here, and you go to the row right above it, which would be He, and you put that in brackets, and then you don't include the 1s2. You just put this in brackets, He in brackets, and you drop down to the next row that carbon or whatever the element is on, and you start from that number and put 2s2, and then go over here and put 2p2, looking like this, which is the condensed version for carbon.
Ionic charge is a charge on an ion that is equal to constant charge E multiplied by an integer from 1 to 15.